Good morning, good evening, everyone. Thank you very much for joining this iNEMI call for participation webinars for iNEMI project. This is the low temperature material discovery and characterizations for first level interconnect project. My name is Tsuria from iNEMIs. This is today's agendas. I will introduce this project cheers, then briefly talked about the iNEMI new project development process. Then I will pass to this project leaders, Shripad. Then he will explain about project outlines, including those items. Then I will explain how to apply and join this project. Please mute your lines during presentations. So first, let me introduce project cheers. Project leaders is Agokle Shepard from Intel, and co-leaders, we have two co-leaders, Russell Kasberg from IBM and G. Lim from Indium. Then I will be managing this project. This is a brief the iNEMI new project development flow. First, new idea, we received new ideas, new input from the iNEMI members or non-members. Then we will hold a very small group, then develop the statement work and outlines of projects. Then we will start this project. Therefore, the input and until the planning of this project, the discussion is open to industry. So we receive, so non-members can join these discussions. Then we can develop the new project. Then after the executions, iNEMI, the membership is required to join this project. So if you would have any suggestions, then please let us know. Please contact any iNEMI staffs. Then we can discuss your suggestions. Then we would like to discuss on the definitions or planning of the ideas. Okay. So now let's talk about the project overviews. I will pass to Shripad. So let's switch to the screens.
Thank you, Tomita-san. Can you hear me okay?
Yes.
Surya-san?
Yes.
Thank you.
It's good.
Let me share my desktop. You can see my screen?
Yes.
All right. So thank you for the background. So with that, let's dive into first the motivation of the project. So there have been multiple uh, types of work being done on the second level interconnect for low temperature solder. And this work is the basis for us looking at it for the first level interconnect. The drivers that are critical are related to both process challenges to first level interconnect, material properties, and the reliability, performance, and feasibility. So the first and foremost challenge with respect to first level interconnect, as we see in multiple industrial as well as academic roadmaps, is the warpage of the die. So as the die is becoming thinner and many cases dies becoming larger, such as high-end server and AI applications, the warpage of the die during the bonding step, die to package bonding step, is increasingly becoming a big challenge. So there is a need to help minimize that warpage challenge, which is primarily caused by the elevated temperature of bonding. The second key motivation for this project is the temperature sensitivity of different dies that are being bonded or components such as sensors, HBMs that are bonded. and also the temperature sensitivity of the substrates based on the buildup. So there is a need to do the die to package bonding at a lower and lower temperature via being able to melt this solder at lower and lower temperature. So these two are the primary motivations for us looking into this low temperature solder as a first level interconnect. And the other main driver for this project would also be to reduce the energy consumption and minimizing the carbon footprint of this entire bonding assembly process. So those are some of the main project motivations with which this team has started to explore and come up with the overall scheme for how we are going to characterize and study this low temperature solder for first level interconnect. Now, before we move into the details and the timelines for this project, one thing to clarify is these low temperature materials could be solders typically which are alloys with low temperature materials such as tin bismuth, tin indium, tin um, uh, gallium, etc. There could be some combination of these alloys as well. And the primary focus of this project is going to be between the die and the package or stack die and the package. It's not necessarily looking at this die to die interface, although the learnings would be applicable thereafter. So the purpose of this project, and this will step into how we are scoping out this project in multiple phases on the next slide. So the purpose of the project first and foremost is to understand the need and impact of low alpha, low temp materials and their availability and the current status of use for first level interconnect. The reason to look into this is there is some literature data and past modeling that exists out in the literature that does indicate that there is a sensitivity of alpha emission from these low temp material solders towards silicon transistor performance and the electrical performance. So that's one of the first purposes of this project, to study that and find out the availability of these low alpha material solders as well. The second key purpose of this project is then to predict via modeling the effect of various low-temp materials and processes on the interconnect integrity. And this integrity will comprise both of mechanical as well as electrical integrity via modeling. And then the third key purpose of this project as an outcome would be to select low temp materials and processes using these first two objectives uh, based on modeling studies, and then to build actual test vehicles in order to characterize the changes in the low temp characteristics of the interconnect, which are comprising of these low temp materials, and then compare it to the standard melt alloy material base interconnect. This characterization will be focused on three aspects. The first is the mixed order interconnects, which are different than the typical tin silver base interconnect. How are they behaving with respect to the joint formation itself with the bumps and the pillar? Then the second is mechanistic characterization of the interconnect, mainly all the warpage and thermodynamic, the thermomechanical behavior because of the differences potentially from the low temp material base IMC and the grain structure evolution as a function of multiple assembly reflow cycles. And then the third key objective is to study different failure modes of this first level interconnect after temperature cycling and temperature shock. Compare that to the typical high melt tin silver solder interconnects. So those are the top three objectives of this project. Now, before we move on into the details of the execution phases, one note to clarify during this project is this low temp solder between the top die to the base substrate could be comprised of either entire low temp material, such as having, say, tin bismuth on both sides, or it could comprise of having this low temp solder only on one side. For example, only on the substrate side, as depicted in this first image, or only on substrate side with some portion of that solder with low temp material, could be on the die side or some combination thereof, where the main copper core is potentially enveloped by some other solder material, and then low temp solder becomes kind of a secondary alloy system in this entire system. So we are calling this as hybrid interconnection or a mixed alloy interconnection. So we will study which particular aspect of the combination of these low temp, high temp materials for the first level interconnect would give us an optimal mechanical and electrical properties we are modeling first. So we are not restricting ourselves to just having low temp sort of everywhere. Okay. So with that being said, the scope of the project is going to involve two phases. The phase one study is going to focus on the current status of low temp material for first level interconnect, including an industry survey to explore what is the low alpha count material definition, what is the current usage in the different products, and what is the current availability. This survey would include general comments about the low temp materials, uh, which could be the low alpha material for current and future direction. Then in that phase, we will also in parallel, not necessarily in series, conduct simulation studies to characterize and understand mechanical behavior of these mixed geometries of low temp material interconnect. This modeling will be dependent on the feedbacks, inputs from the partners in this project from the industry, such as the scope for what bump pitches or the envelopes of the bump pitches to study, the types of materials, and the layout of the interconnect. And this simulation will focus on the warpage or the thermomechanical characterization through multiple reflows as a function of these low temp materials, and also evaluating different collapse ratios as a function of this reflow. And it will then characterize mechanical performance, for example, stress strain behavior, and maybe some electrical characterization as a function of low temp alloy properties. Based on the outcome of this phase one, we will move on to phase two of this project, where we want to assess the qualified mixed order interconnect for reliability studies. And that will involve, number one, assembling these test vehicles that the team will come up with using different low temp material for the first level interconnect, mainly for die to substrate type architectures. And this phase would involve designing those right TVs, having the right alloy materials of the low temp material type, uh, dependent on the feedback from the project members, industry needs, and also this outcome of the phase one. And then we would evaluate the items confirmed by availability of equipment, different resources provided by in-kind contributors for this project. Some of the examples of what characterization would look like out of phase two is studying the voiding performance of this first level interconnect, characterizing the reliability and mechanical uh, behavior through temperature cycling, electromigration, bake and aging cycles, and then also perform uh, analysis such as cross section or um, any other typical FA characterization techniques, and come up with what the behavior of the low temp solder for first level interconnect would look like. What this project does and does not include, just for clarity, this is not exclusive list, but kind of enveloping the scope kind of list. So what it does include is assessing low alpha material needs, their requirements and availability based on the initial survey, and also studying the impact of mixed alloy systems for this first level interconnect. And as I said in the previous slide, the scope is primarily for first level interconnect between die to package, although learnings would be leveraged from second level interconnect studies from the past and would be applicable to maybe stack die, die to die system as well. But the scope will primarily focus on collecting data with first level interconnect for die to package. And then the outcome of this project would define and provide technology readiness of these low temp materials for first level interconnect. What it won't do is recommend any particular low alpha materials or recommend any particular alloy or process uh, or developing any standard. That's not what is the scope of this project. Scope is to characterize and study these first level interconnect with low temperature solder and discover those systems which are compatible. It won't focus on the second level interconnect, like I said, but we will leverage the learnings. It won't repeat any existing or prior work, and it will be not be biased towards any specific supplier geography or market segment. And as an outcome of this project, what we would anticipate to see is list of issues that are expected to be addressed and resolved in future. For example, out of all this characterization, we would identify gaps and reports any results of testing, and we would also understand what the future direction could be for this area. The second key outcome of this project we expect is understanding the need for low alpha material for low temp solder first level interconnect and sharing the survey results among the project members, including this low alpha level impact and requirement of this first level interconnect. Then we will also identify potential candidates of low temp materials and processes through modeling, and then would establish the baseline data demonstrating feasibility of employing this low temp material for first level interconnect. Summary of this outcome and the project would be reported and will be available to all iNEMI members of this project, and then the project results will be published to future academic conferences. And the last slide to note is on today's call for participation, what the members could expect. This is not an exhaustive list, but this is what we think is an outline of the types of tasks and the resources that would be required. They're bucketed in three kind of groups. One is simulation related tasks. One is evaluation or experimental data collection. And then the third is actual data analysis and results. So the types of resources for simulation that this team would uh, expect is modeling studies, for example, studying the interconnect systems. The scope will be decided after the team is formed and starting. The simulation would include probably thermal and mechanical simulation, as well as some electrical performance simulation, of course, based on the details to be discussed by the team once it's started. And then reporting this data and interpret the results to feed into the next phase. In the next phase, the evaluation would include different material supply, for example, different interconnect alloy materials, substrate dyes, and any other resources that are needed from the material side, fabrication of the actual test vehicle, and then validation of this test vehicle's results after thermal cycling through X-ray, any electrical testing, or any other FA techniques. Doing the actual thermal cycling, temperature shock, bake, electromigration studies through reliability stresses, and then the actual failure analysis of those. All this would fall into phase two of the evaluation of this project. And then the last but not the least is analyzing all this data that is generated, reporting, and then consolidating the final report as an outcome of this project. So those are some of the types of resources that this team would be looking forward to for people to be joining from this call. And then in terms of how we envision this project to proceed is outlined on this slide. In phase one, we expect the industry survey defining the scope and objective to the next level of details, that to take about a quarter or so. And in the meantime, we will start comprehending the survey results and reporting the survey results from the low alpha material. That will take about entire first quarter of the project kickoff. And then in parallel, we would start doing the simulation for thermomechanical characterization of the low temp material based first level interconnect. We expect that to continue for first 2 to 4 quarters. And then out of the outcome of this first year of the project, we will move into phase two. The phase two involves actual conducting the experiments, selecting the right alloy, and all the outcomes of the learnings from the phase one, and then actually collecting the data, analyzing, testing, and then doing the reliability. All that we expect to take close to about a year to 2 years worth of time. And of course, once we start going into the project, we will be able to um, refine and fine tune details of these timelines. But this is the rough outline of what we envision throughout the life of this project. Okay, so with that, I will pass it on to Surya-san.
Thank you very much, Shripad. I'll take up. Okay, now I will explain how to apply the project participations. We have two documents. The one is the SOW, Statement of Work. This document includes the project scope and task plans or schedules. And also the another document is project statement. Participating companies is asked to sign this PS and returns to the iNEMIs. Then you will join these projects. So these two documents you can download from the iNEMI website. Then I will give you the link where to get those two documents. And as I mentioned before, that the iNEMI project requires iNEMI membership. So if you are not the iNEMI members, then please contact us. Then we will explain how to proceed and come to be iNEMI members. Yeah, as I mentioned, that the SOWs and PS can be find and download from this link. I would also send this document later on. Then sign the PS and send to this email address or myself. And if you have any questions, please contact me. And for the sign up, due is May 8th. So please send the signed PS before this date. And the plans to start the kickoff meetings, we plan to have May 8th from 10 a.m. Japan time. This is kickoff meetings. Then once I will receive the intentions or signed PS, then I will send the meeting invitations to the people who sent the signed PS. And so right now we plan to have a weekly every Thursdays from 10 a.m. Japan time. This is for the 9 p.m. Eastern time, I guess. Now the questions. If you have any questions, please unmute your lines or use chat box and write your questions. Any questions? Let's see. Let me see. No, no chat box.
Surya-san, this is Morgana. So thank you for the presentation. I joined a little bit later, so I
Okay.
wait for your presentation and then I'll get back to the team in case I have any questions.
Oh,
Thank you
okay.
very much.
Okay, that's fine. And don't hesitate to contact us and ask questions if you would like to know more. Any other questions? Um, as Shepard mentioned that we plan to run the simulations for electrical, mechanical, and thermal. Then if you would expert on that field, then please the supporters collaborate with us. Then let's work on the modelings and simulations. Then if it may be even you're not iNEMI members, but you have such capabilities, then please contact me. Then I think I can, have the specific, agreement between such companies to run the simulations modelings. Um, if no questions, then before we will finish this webinar, Shripad, do you have anything you want to talk to the participant?
Uh, no, just on a closing note, expanding on what Surya-san just mentioned, in case there is any question, any more suggestion on this project, or you want to get more information about the technical details to get involved, please reach out to any of us, Surya-san, and then we would be more than happy to discuss those with you. We are happy to share the feedback and get the inputs as well. So.
Good, thank you very much. And also, I got one note in the chat box from Yuan. The iNEMI membership is based on the company levels, not individuals.
All right, understood. Thank you.
Okay. If you don't mind, are you the simulations expert or other professional field?
On my side, is working for AIM Solder.
Oh,
We
I see.
headquartered in Montreal, Canada. My specialty is solder alloy development
Product materials.
and the soldering failure analysis. Yeah,
Okay.
like cross section.
I see.
Yeah, something like that.
Okay.
Okay,
That's it.
thanks.
Thank you very much. Okay. If no other questions, then I would like to finish this webinars. Then, as mentioned, I will send this the presentation documents to all of you. So please have a look, and also you can get the additional information from iNEMI website. This document includes the link to access to iNEMI web pages. Thank you very much, everyone.
Excuse me.
Yes, yes,
Yeah, I have a short question.
yes.
Yeah, I just got familiar with this enemy. I don't know a lot about that, but it seems interesting to me. So, am I right that it's like somehow just for companies to be part of this project and be a member of that? Or like some researchers can be also a member and working?
Oh,
Like, for instance, I'm a PhD student, I'm working in the packaging stuff, but how I can be part of that?
well, when we would do a surveys, then probably we needs the several the input or the techniques, the make a questionnaire. So yeah, that's why it might be good to have your support if you'll be interested in.
All right. Thank you.
Any others? Okay. Thank you very much again, and hope to have you at the kickoff meetings.